So we'll be looking at question 14 now. The value of the pronumerals in this diagram are. Now, we've got here a relatively complex shape, which reminds me of a geometry law that we've learnt, specifically in the tangent section. We know that if we have this angle here, XPB, then that circle represents, then this angle would be the same, PAB. And this angle here, represented by an X, YPA, is the same as angle PBA. So we need to establish the same thing for our diagram. So angle X is equal to this angle here, and angle this is equal to that angle there. So let's highlight that, and I'm going to use yellow here. They'll be the same. Also, these will be the same. And therefore, X is equal to 47 degrees and Y is equal to 59 degrees. Let's go through and see if I can find that. X is equal to 47 and Y is equal to 59. On to question 15. Find the value of n to 2 decimal places. So it's a relatively straightforward one, and it's going to be right-angled trig. So this is the hypotenuse and this is the adjacent because it's next to. Therefore we use cosine 13 degrees is equal to 4.6 on n. Whenever you have the unknown on the denominator, we can do a little cheat method, which is to swap those. So n is equal to 4.6 on cosine 13. Plugging into your calculator, shift divide, and then putting in 4.6 on cosine 13, close your bracket, and you have 4.72. So n is equal to 4.72, add your units, meters, and there's our answer. Question 16, looks like we need to make a diagram here. A ladder rests against a wall. If the angle between the ladder and the ground is 35 degrees, so we start off like that, and then we've got a ladder, we've got a wall. Okay, you can draw that if you like, doesn't really matter. So the ground is 35 degrees, so 35 will look something like this. 35 degrees, and the foot of the ladder is 1.5, so this is the foot here, and this is the point in which the ladder is leaning against the wall, and this is 1.5 meters. Now we assume that it's built nicely, so it's at a right angle. How high up the wall does the ladder reach? Give your answer to 2 decimal places. So we want to work out that there, which I'm going to call x. So we have right angle trig again because we know an angle, a side, and we want to figure out another side. So let's label our triangle, and I'll put a green there. This is adjacent, and this is opposite. So katoa says tan. So tan, put in an angle, 35 degrees, is equal to opposite on 1.5. So x is equal to 1.5 times tangent of 35 degrees. And if we put that in, 5, shift 3 for tangent, 35 degrees, close your bracket, enter, and it says to 2 decimal places, so it will be x is equal to 1.05, and our units are meters. So it says how high up the wall does a ladder reach? We say it reaches 1.05 meters up above the wall. Question 17. Determine the size of angle alpha given your answer to 2 decimal places. So we've got another right angle trig, and let's label our sides. Well, this is opposite our right angle, so this is an H just here, hypotenuse, and the angle here, this is opposite our angle, so we've got O as well. So katoa, so this is a sine one, sine alpha is equal to opposite on hypotenuse, sine alpha, sub in our values, 3 on 5. Take an inverse sine, okay, and that's found here in trig, shift divide, and put in 3 on 5, close your brackets, and we have alpha is equal to 36.87 degrees. Why is that? Well, the 9 is going to round up that 86 to a 87. Question 18. At a certain time of the day, a post 4 meters tall casts a shadow 1.8 meters. So let's draw a diagram to represent this. It's 4 meters, and it casts a shadow 1.8 meters. Post is vertical. What is the angle of the elevation of the sun at this time? That sounds like we want to work out that angle of elevation there. So answer to 2 decimal places. Yet again, we are going to use right angle trig. This is our opposite, this is our adjacent, and we type in tan theta is equal to opposite 4 over adjacent 1.8, and then to get our angle by itself we take the inverse tan of both sides, and therefore we get inverse tan, shift divide for our fraction button, 4 on 1.8, close our bracket, and we have theta being 65 and it says to 2 decimal places, go to the third. The 2 isn't going to round up the 77 to 78, so we just write 65.77 and add your degrees. Question 19 works like this, and we might do that in the next video actually.